All right, so this last application of lines and angles and stuff is related to this drawing here. So you can see that we got two lines, M and N, and they are parallel. So now parallel, if you're not sure what the definition is basically two lines that are going in the same direction and they never intersect each other. So railroad tracks, stuff like that, they just never cross. And so once you have those two parallel lines, there's going to be a third line which is going to intersect them both. And that third line is called a transversal. So you got M and N are your parallel lines, you got Q as your transversal. And as a result, you're going to get 8 angles in here. Now there's lots and lots of relationships that you could develop from this, but I'm going to break it down to 3 generalized statements. So the first one is that all acute angles are equal. So that is a blanket statement that will tackle things like angle 2, which we can see is less than 90 degrees. Angle 3 is less than 90. Angle 6, angle 7. So anytime you have two of those 4 angles, any two of those 4 angles, they have to be equal to each other. So you can get a lot of different equalities from that, based on the type of problem that you were given. So that's a really good blanket statement. All the acute angles in that diagram have to be equal to one another. Likewise, we can say that all obtuse angles are equal. So angle 1 is obtuse, angle 4 is obtuse, angle 5, angle 8. Those are all obtuse angles, so they're all equal to one another. So that's the first kind of group. You have these groups of equal angles. All the acutes are equal, all the obtuses are equal. The other statement that you can make, the last one, is that one acute plus one obtuse equals 180 degrees. So again, no matter where you're looking in that diagram, if one of the angles you grab is acute and the other angle you grab is obtuse, they have to add up to 180 degrees, no matter where they're located. As long as they're in that diagram, no matter where they're located, one of each has to total 180 degrees. So that's the relationships that you can establish with these. So really this whole type of problem boils down to what type of angles are you given? Are they acute? Are they obtuse? Do you have one of each? What do you got? So let's take a look at a couple problems. So we got our 2 parallel lines cut by the transversal. So we have this angle up here, and then we got this angle down here. So what kind of angles are they, and what can we say about them? Are they equal, or do they add to 180 degrees? That's really your only choices. So are they equal, or do they add to 180? What do you think? Look at the size of them, remember. So this angle here is bigger than 90 degrees, so that one's obtuse. And this one down here is also bigger than 90 degrees, so that one's obtuse. So you got 2 obtuse angles, they got to be equal. So set them equal to each other, and now solve for x. So let's move our 2x over. So we got 4x minus 51 on the right side now, and now we can get rid of the minus 51 by adding. So it looks like we got 112. And then if we divide by 4, well, 4 goes into that, looks like 28 times. But how do you know you're right? You better plug it back in and check. So let's plug in 28. 2 times 28 is 56. 56 and 61 looks like 117. All right, what about this one? 28 times 6 looks like 168. 168 minus 51, I believe, is 117. So it does check. The angles are equal, so we're good. All right, what about this one? Well, again, you got your parallel lines, you got your transversal. So this angle up here is acute or obtuse. Well, it's in the same spot as this one, so it better be obtuse. This one, though, you can see is definitely smaller than 90 degrees. So that one's acute. So now we must have to add these. So add them up, set it equal to 180. So it looks like we got 10x plus 10 equals 180 once we combine our values. And now we can lose the 10. So we got 10x equals 170. So it looks like x equals 17. All right, still got to check it. Yep. So if we plug it in here, 3 times 17 is 51. 51 minus 1 is 50. So that's a nice angle. So 17 times 7, well, that sounds like 119. 119 and 11 is 130. So 130 and 150 add up to 180, so we're good. All right, so not too bad, hopefully. You got these nice diagrams. You really are going to be pigeonholed into just a certain few types of setups. I said equal is going to be one of the big ones. Equal to 180 is another one. Not equal to 90 is really only the third one. That's it. 3 possible buckets that you can do with these. Now, one last twist. Got to throw in a twist. We got a word problem. Yep, a word problem. I know. The complement of an angle measures 10 degrees less than 1/5 of the supplement. Find the measure of the angle. Well, okay, we got to set up some statements to kind of describe these different components. So we need something that describes the complement, we need something that describes the supplement, and we need something that describes the angle. Well, let's start with that. Let's let x equal the angle. All right. Now we also need the complement and the supplement. So now, what do we know about complementary angles? What do we know about supplementary angles? Well, remember, complement means they have to add up to 90 degrees. Supplement means they have to add up to 180. Now, a way to keep that straight in your head is think alphabetically and then numerically. 90 comes before 180. Complementary comes before supplementary in the alphabet. So that's how I keep them straight. But now, how do we describe the complement and the supplement? Well, I would recommend you think about it logically. Let's plug in a number for the angle and figure out how we would get the other pieces. So if I had an angle of 30 degrees, what would that force my complement to be so that it adds up to 90? It's going to have to be 60, right? And the way we would have gotten 60 is if I had subtracted 90 minus 30. 90 minus 30 is my 60. So if I change this angle to 40 degrees, if this was 40 degrees, I'd have to subtract 40 from 90 degrees, which gives me my 50. So no matter what angle I start with, I have to subtract it from 90 in order to get my complement. But if I'm starting with x, I have to subtract x from 90. So this expression is going to be 90 minus x. What do you think the supplement's going to look like if they add up to 180? You got it. It's going to be 180 minus x. So that's kind of a weird scenario, but it works. That's the thing. So no matter what angle you plug in here, it's got to get plugged into here, which generates that complement. Plug it into here, it generates that supplement. So you have all those pieces now. So now we got to go back to the original statement. So the complement of an angle, so which is this 90 minus x, measures is another way to say equals 10 degrees less than 1/5 of its supplement. Now remember, of means what operation? 1/5 of its supplement. 1/5 times its supplement. Now, what about less than? What operation is less than? It's subtraction. Now, do we have to worry about this subtraction though? So is it going to be equal to this? It seems like it, but it's not. Sorry, had to do it. It's not, because remember, less than is one of those reverse subtraction expressions. So less than reverses it, fewer than, subtracted from, that reverses those. So this isn't quite right. It's going to be 90 minus x equals 1/5 times 180 minus x minus the 10 at the end. So got to be careful with those phrasings. So less than is a reverse subtraction. But now we have our equation, so now we can start to break this down. Now, if you don't like the fractions, if you have a fraction that's a terminating decimal, I would say do that. So 1/5, we hopefully know that that's equal to 0.2. So if you change it to a 0.2, it's going to make life a little easier for you. So let's work it through with that. So 0.2 times 180 is 36. Whoops, almost made a mistake. We do have to distribute though. So you have to think of this 180 minus x, this 90 minus x as a one piece, one component. So you do have to distribute. And try not to break your lead. All right, so that distributes it in. Now we can do a little bit of combining. So we got the minus 10 and we got the 36, so we can combine those. So 90 minus x equals 26 minus 0.2x. And now we can start moving stuff around. Now, we always like to move the smaller of the two x's, or whatever the variable is. But be careful. It's tempting to want to move this one, thinking it's smaller, but this is negative 1x. So it technically is smaller. So I'm going to add x to both sides. And then again, that's a 1.0x. So I got 90 equals 26 plus 0.8x. Minus 0.2 plus 1 is positive 0.8. All right, and now we're almost there. So we got 64 equals 0.8x. Let's divide by that 0.8. And so x better be 80. 80. So what's our answer? What's the question you want to know? Find the measure of the angle. Well, the angle was x. X is 80. And we're done. Don't forget don't forget the degrees though. So 80 degrees is going to be our angle. Now you can find the supplement, you can complement if you want, and double check the original problem. That is always optional, but if you're not sure, it's always encouraged. So, all right, that wraps up 9.1. We'll see you in 9.2. Take care.